Yes, sir. You are live and you are ready to go, sir. இப்போ admit all கொடுத்துறேன் sir.
கொடுத்துருங்க சார்.
You are live. You are ready to go, sir. Admit all கொடுத்துறேன் sir. Start, sir.
No.
Start பண்ணுங்க sir.
ஸ்டார்ட் பண்ணிடலாமா?
Yes, sir.
Good morning, everyone. I am Dr. A. Kumar, HOD Chemical Engineering Department, Savitha Engineering College, Chennai. Happy to introduce today's speaker, Mr. V. Narayanamurthi, Assistant Manager at Hyundai Motors, India. He has completed MBA in Safety Management. He is a member of Certified OHSAS and auditor of ISO 14001. He is a trainer of process safety from drilling of experiments, failure mode effective analysis, emergency management and problem solving models. Now he is going to deliver a speech on role of chemical engineering in industrial safety. Thank you. Okay, sir.
Narayanamurthi sir, you are ready to go, sir.
ஸ்டார்ட் பண்ணுங்க சார். நாராயணமூர்த்தி சார். சார் ஸ்டார்ட் பண்ணி சார். வெல்கம் மட்டும் சூட்டாச்சு. வாங்க 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 சீக்கிரம். வாங்க 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 வாங்க. ஸ்டார்ட் பண்ணுங்க.
Shall we start?
Start பண்ணுங்க சார்.
Welcome to everybody. Today is a webinar on role of chemical engineering in industrial safety. My name is Narayanamurthi. I am working as assistant manager in Hyundai Motor India Limited. And the agenda of today's meeting is mainly the evolution of chemical industries, what are the different classifications of chemicals, what are the major disasters in chemical industries, what is safety in chemical engineering, what is process safety management, and what are the benefits of process safety management, and conclusion, question and answer session will be the main agenda of today's meeting. So the evolution of chemical industry starts somewhere around way behind 5000 BC, where the invention of fire played a very important role. Clay was used for making of utensils. In 3000 BC, Egyptian tombs were covered with soda ash, and we were able to ferment vinegars from grapes. In 1600 AD, inorganic chemicals were invented to preserve meat, and gunpowder was used in local artillery and warfare, and soap invention was a major role in 1600 AD. In 1700 AD, 14 elements were identified. In 1800 AD, 100 elements were identified. 1850 to 1900 saw the evolution of organic chemicals and radioactivity, which played a very important role in generation of electricity and as well as in warfare. In 1930, started a new revolution for the Second World War, where plastics and petroleum refining played a very important role. That also started the evolution of polymer industry throughout the world. In 1950 to 1960, various toxic and corrosive chemicals were invented using high temperatures and reactors. Thus started the industrial revolution throughout the world. So this is the basic evolution of how the chemical industry evolved from 5000 BC. Based on the various reactivity of the chemicals, we have chemicals classified. 13 type of chemicals are classified based on the hazardous components actually. The first is flammables. Flammables are again classified into 3 types: class A, class B, class C, based on the flash points. Second is explosives, which are either air reactive or water reactive, or they are explosive because of the composition of various chemicals. Corrosives, as you know, based on pH, is acids and bases. Toxics are basically which create human to environment, which create danger to environment and to human based on exposure. Oxidizers are basically chemicals which act with oxygen, which give out various toxic components. And we have compressed gases. Compressed gases are stored mainly in cylinders or mainly in bullets. And next is cryogens, and next is air reactive, and next is water reactive. On the right hand side, you can see the various symbols of various chemicals, which you can see. Actually, the symbol, the square shape, which is red, indicating inside, it is usually a danger. As we see in traffic signals, the red means you stop. The same thing applies to chemicals also, where the flammable symbol inside the red square indicates it is actually flammable. Oxidizing means you have the O symbol over which there is a flame, it's oxidizing. Explosive means it is like a cracker, so it's explosive. Then you have got toxic. Toxic is where you have the bones and skulls are depicted on the chemical name. Corrosive is, you can as you will see, it reacts with various metals and it usually decomposes the metals. And compressed gas is shown by a triangle with a cylinder inside. Cryogenic gases, we react to everything, so that is shown as a triangle inside. Air reactive is shown by a symbol where you can see the bottom is actually chemical, top is air. So we have got various symbols regarding the classification of chemicals. As per government rules, the classification of chemicals needs to be displayed in the can or in the bag or in the container where it is stored. So environmental hazard is shown by a fish, which is supposed to be coming out of water. So that needs to be shown as environmental hazard. So these are the various classification of chemicals which is in the world. Based on the reactivity, based on the chemical composition, based on the constituents of the chemical, they are further classified into various elements actually. So these have been the major chemical disasters throughout the world. It is a BASF explosion. BASF is a factory which manufactures various chemicals to fertilizers as well as for artillery. So it happened in September 1921, where 4,500 tons of ammonium nitrate and ammonium sulfate exploded. In ancient theory, in 1919, there is a common saying that the sulfate concentration, both ammonium nitrate and sulfate concentration, to be maintained at 50-50% to make sure that the reactivity does not explode. So, but the concentration of ammonium nitrate literally exceeded 60%, which resulted in major explosion. Almost 80% of homes were destroyed. Over the radius of 25 kilometers, death really occurred to 5 people. So this was the major industry before the World War I actually. So in 1947, where there was a boom in the petroleum industry and there was the boom in the fertilizer industry, there was an explosion in the French ship actually. During the unloading of ammonium nitrate, people started using non-flammable and non-toxic tools, iron tools, which resulted in the explosion of ammonium nitrate. At that time, fire extinguishing was not a famous thing throughout the world. So the captain used steam to extinguish the fire. The fire got aggravated, mainly 3,500 people injured and 5,000 people were killed. This resulted in the dockyard implementation of safety in dockyard measures. As you all know, gas leak. India was at the fertilizer revolution, agriculture revolution. So we need to manufacture a lot of fertilizers to increase the demand of the food industry in India. So manure was being produced in Bhopal, and 42 tons of methyl isocyanate was released, which really resulted in 18,000 people dead and over 5 lakh people are affected. Till now, there is a case going on to give the remedy to the people. So gas leak in Bhopal created a major change in the government actually, and after this only, the occupier was held responsible. Occupier is accounted for responsibility for any hazardous leak in India. Before that, any hazardous leak, hazardous accidents, occupier was not held in law. He can't be held legally in law. After the gas leak in Bhopal, occupier was held responsible, and 41D, a special clause was introduced in the Factories Act to make sure that occupier is held responsible for the gas leaks for any hazardous occurrences. So this was a major in Seveso, Italy. The toxic cloud release of tetrachlorodichloropyroxene is a very dangerous chemical actually. People didn't know about the use of this chemical. The reactor was overheated and burst. What happened is the toxic cloud releases, till now this land is become uncultivable because of the release. 1,800 hectares of land become uncultivable. Till now, people have isolated the area actually. Children are born with cancer, and major women, about 83% of women, they don't give birth to a normal child. Almost 220,000 people are affected and 80,000 cattle were killed. So this incident actually in 1976 brought about a major revolution in the European Union, which triggered the closure of major hazardous industries in Europe without any safety regulations. So this is March 23, 2005, where there is a hydrocarbon vapor explosion in the British Petroleum BP Texas City refinery. Almost 15 deaths were reported. And British Petroleum is basically a UK company, and it was forced to sell to US for $2.5 billion. It is actually 1/10 of the profit of the company actually. They sold it for a meager amount to US actually. So this is a major China was competing in the world to become a superpower. So all major chemical industries were opened in China. So they want to compete with the USSR and US. So they started the process of petroleum refining process. And that time this institution was acted in Petrochemical Corporation. Jilin is a major producer of both petrol and diesel to supply to China. So actually nitrobenzene rectification tower got exploded. 100 tons of benzene and nitrobenzene flowed in Tongai River. Tongai River is the water police for almost 5 provinces in China. The water pollution results in blood cancer. Still, and 1 lakh people are evacuated from this place. Till now, this place is not being used because of the fear of the people and fear of chemical pollution. And as you all know, LG Polymers in 2020, the toxic waste of styrene which happened, 2,800 tons of styrene was released in the atmosphere. 13 deaths and 1,000 people are affected. Company is being closed temporarily. What is the cause for this reason is the temperature, styrene was stored in a storage tank. The 22 degrees was to be maintained in the tank. Due to COVID lockdown, we need to prevent the polymerization of styrene. So tetrabutyl catechol needs to be added to the tank to stop the polymerization of the styrene, but that was not added. The temperature due to lockdown, as is summer in Visakhapatnam, the temperature was not maintained. The chiller plant was switched off for almost 24 to 48 hours to bring the plant to maintain power consumption in the plant. So slowly, the vapor in the tank slowly started expanding, and an emergency procedure was not available. The plant was started in 1998. That time, the density of population was not allowed in the 14-kilometer range. But as the population slowly increased, people started moving towards the company. Municipal authorities also gave permission for the people to locate their homes near the factories within the 3-kilometer radius. And one more thing, they did not obtain the license for storing such a large quantity of hazardous materials in their site. The company obtained actually legal certification for storage of only 1,800 tons. But due to expansion of industries and due to expansion of various polystyrene requirements in the India, LG Polymers started storing this styrene in large quantities. So this led to the increase in the temperature of the tank, which led to the release of 2,800 tons of styrene in the atmosphere. The people in the surrounding villages, they did not know what to do in case of a styrene leak. The company did not contain any emergency plans to evacuate the people in case of any leak. People were not aware of what to do in case of a styrene leak. People started running in roads because of styrene leak. The people stayed inside and kept their door closed and windows closed. The styrene leak would not have affected them. 12 people were immediately died, and almost 1,000 people were affected. Styrene usually affects the eyes, basically, and affects the mucous membrane, and slowly it affects the kidney, which leads to blood loss as well as death. So these are the major accidents which actually change the total chemical scenario. Till now, the compensation for the people is giving. Till now, company is not able to open the production operation after this COVID lockdown also. So actually, during this COVID lockdown, the styrene, in order to prevent the polymerization of the storage tank, TPC needs to be added. 500 kg TPC to be added in the tank, but it was not added. And to save power, refrigeration unit was switched off for 48 hours. This will lead to the increase in the temperature inside the tank. And one more thing, oxygen content was not measured. Oxygen content almost dropped to 4%. Human beings need 21% oxygen to breathe. But the overall oxygen level, 3 kilometer radius, dropped up to 4% because of the toxic release of styrene. So this led to the death of 12 people and 1,000 people are affected. And as it happened early morning, the catastrophe was less. It could have happened somewhere around in the afternoon, the catastrophe would have been more. as early morning 3 o'clock, people stayed inside their houses. The catastrophe was less. Only the people who were living outside on the terrace, they were affected by this leak. So next, we will see what is safety. Safety is nothing but safety covers all the three topics: safety, health, and environment. As the definition says, safety is freedom from all conditions that can cause injury. Injury can be small or medium. Ill health. Ill health is exposure to any toxic chemical, death, damage to equipment or environment. So this is the general definition of safety. Safety covers health as well as environment. So the next is accidents. Accident is unplanned. You don't plan an accident. Unforeseen, unexpected event which results in damage and injury is called an accident. So you don't expect anything in an accident. So that is called an accident. If we know that, we can stop it. If we know also, people should take appropriate preventive measures to make sure that the accident doesn't happen. A hazard is nothing but a source of potential damage, harm, or adverse effects on something or someone. It can be to people, it can be to environment, it can be to cattle, it can be to land, it can be to anything. So hazard is a source of potential damage. Potential damage can be from anybody, it can be due to toxic release, it can be due to fire, it can be due to land pollution, it can be due to water pollution, it can be due to air pollution. So risk is nothing but it is the probability by severity based on the hazard. What is the near miss? The near miss is nothing but there is no injury is occurring, no illness or fatality occurs. It is called a near miss. The incident may occur, but there is no incident, that there is no injury, illness, or fatality. So that is usually is called a then you need to write it down. So unsafe condition can be a slippery road, can be steps without handrail, can be workplace environment where is a physical condition which is causing an injury. So unsafe acts. So according to, I will come to the next slide. Unsafe act is any act that deviates from safety procedure, behavioral issues, unauthorized storage, etc. As you see in the diagram, here I can see there is a load. There is a load attached to the hook of the crane. The chain link is cut. Okay, it is an unsafe condition. You have got two people working under suspended load. No people should walk under suspended load. We have got two people who are not aware of the load on the top of them. So they are walking under the load. It is an unsafe act. This is a near miss. The link is getting cut. The load is falling in front of them, but the people are not getting affected. This is an example of a near miss. Suppose the load falls on a person, there is an accident. Now you can understand what is the difference between the unsafe condition, what is the difference between unsafe act, and what is the near miss and what is an accident. The simple diagram it shows you the four different aspects of an accident. So Hendrich is actually what to say is a safety scientist. To be frankly telling you, he has written various theories on safety. Okay, but I am going to give only a synopsis of what he has told. It is actually a 500-page book where he has told about various human behaviors, constitutive factors, the various physical environment which plays a very important role that affects human safety, which indirect affects, which in turn affects the safety of the environment and health and society as such. But according to him, according to the synopsis of his theory, what he says is 92% of accidents are mainly due to the unsafe acts of people. That is, it may be a people, a group of people. According to him, if 100 accidents happen throughout the world, 92% of accidents are due to the unsafe acts of human beings. 6% of accidents are due to unsafe conditions. Unsafe conditions may be a slippery floor, a damaged road, a damaged tunnel, a hanging wire, everything. Everything is related to unsafe conditions. 2% of accidents due to natural disasters. Now, natural disasters are divided into two topics: man-made and nature-made. We don't want to go into the political aspects as well as the economic aspects of natural disasters. There are various natural disasters happening throughout the world. People do it and they put fault on the nature. Okay. So, according to Henry's theory, 92% of accidents are mainly due to the unsafe acts of the people. So, before this is the tip of the iceberg. He is seeing only the accidents. The accident is the tip of the iceberg. Okay. So, these are the various underlying factors. Underlying a big ice is there. We are only seeing the top of the ice. But there is a ice hill, ice mountain under the below the accident. What is that? There are mainly 6,000 hazards. So 6,000 hazards. According to his theory, 6,000 hazards are, before an accident happens, there are about 6,000 hazards. As hazards, I have told you before, is the source or potential to cause injury or ill health or damage to human environment. It is a source of potential. There are about 6,000 potential hazards which are inbuilt before an accident happens. And before the 6,000 hazards are there, there are 600 near misses. Near misses, as I have explained in the slide before, an incident which doesn't create any injury. So there may be 30 minor injuries. Before the fatality happens, there may be 30 minor injuries, and there may be 10 major injuries, and which results in one fatality. That is, what he tells is, first of all, we need to solve the hazards first. Then we have to correct the near misses. We correct these two, these three things will not happen. The theory says. So, our main concentration is not to attack here, we should attack at the base of the pyramid, which is we need to correct the hazards as well as near misses. This is the main idea of Henry's theory, which holds even today in the present scenario. So, why we need, why we have got the various hazards and various near misses, and why we need this process safety management. The process safety management mainly deals with four aspects called plan, do, check, act. Anywhere you go, process safety management concentrates only on four aspects, that is plan, do, check, act. The plan is basically based on assess and define what are the various hazards in the workplace. Then we have to design, implement and construct the controls over it. Then we have to monitor the process. In the case of LG polymers, they had an assess and define problem, that is, the styrene needs to be maintained at 22 degrees centigrade. They had implemented the refrigeration system inside the plant to make sure that the styrene needs to be maintained at 22 degrees centigrade. But the operational maintenance plant of the water was faulty. That is, the cooling system was switched off, so the styrene temperature could not be maintained at 22 degrees centigrade, which resulted in death of 12 people and affecting 100 people. So, process safety management, it is a continuous process. You have to maintain the process. Suppose if you see any flaw in the process or any improvement in the process or any change in the process, we need to again assess and define the process. Then we need to implement controls. Then we need to monitor the same. And then this process goes on like a span, like a cycle. So this process needs to be done in each and every stage of the process safety management. I am giving you just the outline. Based on this outline, you can develop, I will give you examples of how the process goes. So in the process safety management, we need the following information. Without this information, we can't proceed with the process safety management. What is the process safety management content? Process safety information. For this process safety information, we need PSI diagram and MSDS. MSDS is nothing but material safety data sheet of each and every chemical involved in the process. Then we need a process hazard, it's called HAZO. It's a beautiful study. It is being implemented in various petrochemical any chemical industry should follow this HAZOP system to make sure that the process is safe. I will explain an outline about the HAZOP process in the coming slides. Then we need to know about the standard operating procedures. This two-stage comes under plan, do, check that. This two-stage comes under planning. This stage comes under do. Then we need to train the people. We need to train the people to follow the safety procedures. Okay. Then we need to have the permit to work system of the various processes involved and various activities involved in the process management. Then we need to have the emergency response system. In the case of styrene leakage, I will talk about the present scenario. The company did not conduct. We need to have an on-site emergency, off-site emergency in case of toxic release. On-site emergency talks about any hazard or any fire or any explosion or any toxic release occurring inside the plant. Off-site emergency is outside the plant. If any toxic releases happen, how the person is going to get affected, how you are going to evacuate the whole people, and what is the first aid method you are going to give to the people, where is the nearest hospital available to carry the people, what is the mode of transportation to reach the people, where the hospital has got adequate antidote to cure the toxic releases. All these needs to be covered under off-site emergency plan. How many people are going to get affected? How are you going to transport the people to a safer location? And what is the antidote to be given to the people? And how are you going to educate the people? How are you going to alert the people in case of any hazard releases? All these needs to be communicated to the local people through various medias, through various panchayat unions, to various people. The people who are going to get affected due to the release of the chemical or due to the company, they need to be informed, they need to be educated, you need to conduct a mock drill. Mock drill is a simple process where you mock means you do a scenario of a leak and how you are going to evacuate people to a safer location. The human loss, any loss can be compensated, but human loss cannot be compensated. It can be only replaced. So the process safety management usually details about the various hazards available in the process. See, suppose I will show you the example in the coming slides. So what are all the various details required in case of the process safety? First, we should know about the material safety data sheets of various chemicals used in the process. This is mandatory. Styrene, I should know what is the composition of styrene. I will come to the process material safety data sheets. What all should be there in the material safety data sheets? So next we should have the process flow block diagram. Next we should understand what is the process chemistry. What is the temperature to be maintained? What is the pressure to be maintained? What is the reactor parameters to be maintained? So what is the maximum inventory of chemical I need to store? Because in case of a lockdown and in case of shutdown, we need not store so many other chemicals inside our plant. So almost as the COVID lockdown was unprecedented, they stored almost 4,800 tons of styrene, which is a highly flammable gas. Out of which 2,400 got released in the atmosphere. So how much inventory I need to maintain for my production capacity? That also needs to be meticulously calculated. So what is the safe upper limit and lower limit of temperature, flow control, and pressure, reactor conditions? Then we have P&I diagram, pipe instrumentation diagrams. Then we need to know about the electrical ventilation layouts, because in case of any emergency, which part of the electrical I need to switch off, which part of the ventilation system should be shut down, which part should be switched on, everything I need to know. Then design and codes of standards incorporated. Any piping instrumentation or any processor, they have got design codes which is available in the material, which is available in the process. That design code standards needs to be incorporated in the process. Then various safety systems. The various safety systems may be interlocked. Emergency system. Suppose temperature is getting released. Temperature of the system is getting increased. I need to maintain 22 degrees. Suppose the temperature is going 25. So what needs to do? There should be indication alarm. So automatically the AC unit should switch on automatically. Suppose in case case of other temperature rise, for example, 30-degree rise, 40-degree rise, what should I do? How do I measure the volume inside the tank? All these needs to be planned. The planning stage needs to be done. Okay. The next, the material safety data sheet is very, very, very important. For every chemical, we need to have the 16 parameters. Without the 16 parameters, the material safety data sheet does not comply. So, if you are purchasing chemical from a plant, from a supplier, or anybody, so we need to have the 16 parameters, and we should understand the significance of each parameter. Then only we can decide the process parameters, then only we can decide the emergency response team, and then only we can decide the various emergency requirements of the plant. So first is, who is the supplier? This will come to the next slide, emergency contact number. What is the composition of chemicals inside the element? Then what is the hazard identification? What are the first aid measures to be done in case of toxic leak? So with this I need to educate to the people working inside the plant and who are also outside the plant. Then what is the firefighting measures required for in case of any fire, what I should do? What is the handling and storage precaution? How should I store the chemical? What are the conditions to be maintained inside the chemical? How much volume should I store the chemical? What is the requirement of the tank? What is the requirement of the chemical composition? What is the requirement of temperature? What is the requirement of pressure in the tank? All these things to be available. What are the PPEs to be used? What are the physical and chemical properties? Physical means reaction of the chemicals with air, with water, with the atmosphere. What are the various chemical properties? For example, in the reactor there will be two chemicals. What will happen if I mix those two chemicals in a various proportion? Suppose if I mix it wrongly, the composition of chemical is wrong, what will happen? All these things will be mentioned here. What is stability and reactivity of the chemical? Toxicological information is very, very important. Suppose if there is any toxic release in land, water, or air, what will happen? So then, how to dispose the used can or container or used chemical residue? How to transport the chemical? For example, you need to transport it from one location to other location. How do you do it? What are the rules and regulations governed by the present body? What is the other information you need to disclose? That also needs to be mentioned. All the 16 constituents or clauses need to be mentioned in the material safety data sheet. If you have any doubt in the material safety data sheet, don't buy the chemical. So this is the hazardous material identification system. All chemicals, there is an international standard which says that the fire hazard is usually denoted by this symbol with the red shading. This health hazard which is purple or blue in color. If you need to specify any other hazard, others column, we have got acid, alkali, corrosive, oxidizer, radioactive, snow water. Then reactivity, may detonate, shock or heat may detonate, violent chemical change, unstable, heated, stable. So if a chemical is labeled as 1, this is 4, and this purple is blue, and this is acid. So I should presume that the flash point of the chemical is below 70 degrees Fahrenheit. Reactivity is unstable when heated. Health hazard is hazardous. So it will not get any death during exposure. Next is acid. So we need to understand, suppose the number is the HMIS symbol, hazardous material identification symbol, the number is more, then the chemical hazard is more. Simple. The number is more, the chemical hazard symbol is more. So before procurement of any chemical, you should know which number of various. One is the health hazard, second is the fire hazard, third is any other specific hazard, fourth is the reactivity. These 4 must be known and must be labeled in this symbol inside any chemical. That's what the rule says. But in India, almost 60% of the companies don't follow this rule, and we need to improve on this. So these are the various definitions which are given in the material safety data sheet. Material safety data sheet does not tell all this. There is no point to mention that what is TLB should be maintained, this PL should be maintained, this what is LD50, what is LD50. Definition of each and the material safety data sheet gives the various information regarding the various chemicals. It is then flammable. So flammable, we have got three classes A, B, and C. So flammable is deeply ignited below the flash point of 95 degrees Fahrenheit. The flash point is the lowest temperature at which a vapor, at which a liquid produces vapor to ignite. For example, petrol is left in the open atmosphere. Petrol slowly evaporates. Okay. So for fire we need oxygen, heat as well as fuel. Fuel is available, heat is already available in the atmosphere. So petrol, what is happening? Search a source for igniting. So during this what happens is, suppose it finds any other source. For example, there is a matchstick which is nearby. There is a loose relative function nearby. There is a ground where there is storage of any hazardous chemicals that is not grounded properly. So through that fire may occur. So we should know at what temperature that the liquid in order to ignite. So toxic is mainly due to substances able to cause harm to exposure. Exposure can be due to inhalation. Inhalation is to the nose, and one is due to the mouth. The toxic intake can happen, and one is to skin. So these are the possible three ways where a person can be exposed to the exposure. So as you know, coronavirus is toxic to human beings. So what you are doing it? You are covering our nose and mouth with a mask. Simple. So corrosive. Corrosive is the substance which is able to burn or damage organic tissue by reaction. Suppose any acid or base falls in my hand, what happens? That tissue is getting totally deteriorated. So that is called corrosive. PL, in any chemical safety data sheet, there will be a column mentioned in the physical and chemical properties of chemicals, that is PL. PL explains maximum concentration that the worker may be exposed to. So below, above this concentration, the worker should not be exposed to any chemical. So PL means threshold limit value. PL is permissible exposure limit. So PL is threshold limit value. It is for a chemical substances, for example, how many hours, for how many concentration of the chemical the person may be exposed to. That gives TLV. TWA is time weighted average concentration. TWA is the concentration the person can be exposed, the worker can be exposed when working for 8 hours without any harm. For example, I am handling benzene. Suppose the benzene MSCS says the person can work without any PPE for 2 hours. So the worker must be exposed to the chemical only for 2 hours. So it will tell you can use this PPE and work for 8 hours. So the personal protective equipment needs to be worn by the worker before handling benzene to reduce the impact of benzene in case of any intake. The STL is very, very important, where when we are using cyanides and explosives, the STL is short-term exposure limit. The short-term exposure limit only comes up to 15 minutes. So beyond the 15 minutes exposure, the person may die, or he may have any adverse effects on the body. So LD50 and LC50, legal dosage is nothing but which is injected into the body. So 50, suppose the concentration of the chemical needs to be maintained in such a way that it doesn't exceed LD50. LD50 means, for example, in the case of styrene, almost lethal concentration is almost LC50 is only how much? It's only 15 milligram per kg, but it exceeded 2,800 tons. So it's just a 12 people death. So LD50 and LC50, this is mainly meant for exposure in case of any environmental hazard. That is mentioned in the MSDS. So we have to make sure that LC50 and LD50 is within the limits of the chemical exposure. So these are the various terms used in the material safety data sheet. Based on the material safety data sheet, we need to design the process. So this is a process analysis where it mainly describes, as you said, the plan to check act. We should identify the various hazards involved in the process, and we should implement the various control methods which is made to control the process. And the PHE analyzes the consequences of fires, exposure release of toxic materials, and it also determines the various failure methods where the environment or people or fire can happen or it may get affected. So the failure method needs to be analyzed with an engineering control. So PHA team should always include all engineers, operators, supervisors, and workers who have got straight-away experience, and they should have knowledge of codes and specification of various chemicals and various piping and instrumentation which is being used in the plant. See, there are various methods we can do a process of analysis. One is a checklist. Checklist is nothing but a sheet which contains what all to be seen in a process. That is an example of simple checklist. For example, before cooking, what are the things we need to be maintained? That is checklist. So I need to keep ready the gas in good condition. I need to turn on the knob. I need to switch on the lighter. I need to keep the pan ready. I need to keep the oil ready. I need to keep the vegetables ready. So there is a checklist. So we go on, keep on, based on the process or based on the requirement, we tick whatever is defined in the checklist. So there can be a chance of failing the checklist because the checklist mainly depends on the experience of the person, not on the experience of the process. So there is also another method called what if method. So what if is mainly concentrates on the end product basically. Suppose what if is, what if I don't switch on the gas burner? What if I don't switch on the lighter? What if I don't keep the pan ready? What if I don't keep the material ready? So what will happen if we don't keep all the process parameters in ready condition? What are the various failures which can happen due to this condition? So all these things comes under what if method. What if method mainly used in action investigation or in problem solving techniques, not in hazard analysis and process safety management. So HAZOP is called hazard and operability study. HAZOP study plays a very important role in process safety management. The HAZOP study is being done in various process industries. It is actually a session for 1 week. I am only giving a glimpse of what is there in the process safety HAZOP study analysis. A simple requirement of HAZOP is, I will let you know. Okay. So there should be a team from the top management, and the requirements of hazard and operability study is, one, you should have the block flow diagram. I will show you what is the block flow diagram. Then you should have the process flow diagram. Process flow diagram is required for any HAZOP study. And next is the P&I, piping and instrumentation diagram. And next is the various codes and standards. Codes may be a regulatory requirement, standards and specification of recommended practices as per construction, fabrication, manufacturing, inspection. So all these things, construction, fabrication, manufacturing, and inspection, all need to be implemented during this HAZOP stage. Okay, a block flow diagram. I just show you the basic structure of a system. This is a block flow diagram. This is an example of an effluent treatment plant. So where you have got this is a block flow diagram. It is an effluent treatment process of a treatment plant actually. Sir, can I continue?
Sir, continue, sir.
So some people are raised hands, that's what I'm saying. Okay, this block flow diagram mainly concerns about the various process flow usually. So what is happening is, it indicates the various stages where the effluent water runs into the sequence. For example, effluent water is passing through the screening process, there is the equalization process, there is the violation process, there is the population process, there is the tube settler. Coming to the tube settler, the bottom of the tube settler is going to the pit. Then it goes to biological reactor 1, then it goes to biological reactor 2, then it goes to tube settler, then it goes to collector tank. From the tube settler bottom again it goes to the pit. Again, from the pit overflow goes to a clarifier, and again it goes to the dewatering plant, and again from the collector tank it goes to ACF, activated carbon filtration, again it goes to sand filtration, then the water is coming out, slightly there is a two stages in all the process actually. In the effluent treatment plant, simple definition I am giving you, easy to understand. These are the various stages. Block flow diagram usually indicates the various stages involved in the process. Simple. It involves about the various stages. Block flow diagram. That's all. Effluent water contains both solids as well as suspended solids as well as liquid. So we need to separate these two. This simple diagram explains the separation of solids and liquids. That's all simple. We need a cleaning tank where you filter out fine particles. There's the equalization tank where we add acid or base depending upon the pH of the water. Then we have a coagulation tank where we remove the suspended solid. There's a sterile continuously going into the coagulation tank. Solid settle at the bottom. There's a flocculation tank again. There's a tube settler where it's also called a dump tank, where water overflows to the biological reactor, where we check for the BOD, biological oxygen demand. Then we go to biological reactor 2, again BOD is being reduced here. Then we go to tube separator where we check the chemical oxygen demand of chemicals. Then it comes to correction tank where we check all the parameters here. Then it is sent to the activated carbon filter where we remove the TDS of the water, total dissolved 40% of water is removed here. Then we do a sand filtration where there is a fine removal of any supplemental material. Then the filter water goes out for various purposes. So in this stage we check the parameters of filter water. There are 23 parameters to be checked into the water. We check it and we let it out in the atmosphere or reuse it in the process or reuse for gardening and other purposes. The sludge actually comes from the clarifier. The clarifier overflow water again goes to the carbon filter as well as activated filter. So again the sludge dewatering, again we get the sludge back. Okay. So this is the process flow diagram where we see the equipments. Mainly these equipments which are in line. So this is the Hyundai diagram, process instrumentation diagram, where we see the what are the various symbols used for various pumps, compressors, and what is the gate wall, everything can be see here. Then what are the various things to be included in the Hyundai diagram is shown here. And this is an example of a simple Hyundai diagram where only instrumentation symbol is being used, pump symbol is being used. So this I will explain with a simple example. Okay, how to do absorb analysis can be shown as a simple example. This is the reaction tank where we produce a product called C. We require two raw materials to produce C. One is material A and one is material B. So it's a simple reaction. A plus B is equal to C. Okay, this is a simple reaction. So my requirement of the process is component B must not exceed component A to avoid exposure. So component B must not exceed component A. So component A composition should be always on the higher side, should be always more. The quantity of component A should be more than component B to avoid explosion. This is the simple process requirement. So what does the process hazard analysis say? What does a chemical engineering person should do? So he should consider what are the various possible ways where A can cause the minimal flow. Where the following conditions may cause the failure of minimal flow of A. If A exceeds, then may result in explosion. So, what are the various causes which inhibits the flow of A? One is the supply tank may be empty, inlet valve may be closed, pump is switched on, the pipeline which is transferring the liquid or any material that is damaged, the measuring system of A and B, whether it is faulty. Okay, these are the various probabilities which can minimize the flow of A. So this reactor needs to be safe to produce the major component. So these are the conditions. Simple example I am giving you. Simple example I am giving you. So these are the various conditions which can happen, which can minimize flow of A. So we need a triggering mechanism or alert mechanism to exhibit all these. So this is a simple condition we need to put. So what we do, I follow a check sheet. So this is the various guide word used in the Asst check sheet. Okay, this is the various parameters. These are the various parameters. One is flow, one is pressure, one is temperature, one is level, one is time, one is agitation, one is reaction, one is startup shutdown, one is draining and melting. So these are the various guide words which are used in the process. And each guide word should be followed by what happens if the flow is more, what happens if the flow is less, what happens when there is no flow, what happens when there is a reverse flow from the reactor, what happens when more flow occurs, that is as well as when both the components react together, I produce a component C. What happens when there is a deviation in concentration? What happens when the concentration exceeds? What is the other byproduct produced? What is the contamination produced? What is the other component produced if there is any deviation in the process? So all these guide words are done for each and every line, each and every parameter. Suppose for my case, in this previous case, there is only what is the guide word, only flow is the guide word. So I have to apply this flow in all these cases. So I have to apply this flow in all these 5 cases. Okay. Then I need to put it in a sheet. I need to put it in a sheet. Guide word. What will happen more? If there is more flow of A, what is the deviation cost? What are the various? What is the cause of this deviation? What will happen if there is flow is less? What is the consequences? What is the hazard? So how do I implement this control measure? So suppose the pump is not running, the reactor will be switched off. Suppose if B is not, if A is, there is no flow of A, the reactor will stop. When the concentration of A is exceeding certain limit, so I will get an alert indication. I will pump more on B. So all these safeguards available will be maintained. So based on this action to be taken, what are the things I need to check to make sure that this guide will be fulfilled? These need to be monitored. So this is planning, doing, checking, and acting based on this. This is the simple sheet should be done for each and every line, each and every process. This is an example of a Asst study worksheet. So as I told you, the emergency response was very, to be frank, very poor in case of styrene leak and other chemical disasters actually. It is an emergency and nothing but an unexpected dangerous situation which requires immediate action. It is an unexpected dangerous situation. I don't expect the styrene to get leaked in the atmosphere, but I need to mitigate it immediately. So types of emergency can be anything. It can be natural calamities, it can be man-made, it can be fire. The emergency response team needs to be developed. As I told you, emergency response basically first protecting the workers who are working inside the plant and protecting the environment, people, society who are present outside the plant. So every industry should have an emergency response team. So this is a simple layout of an emergency structure, ERT, emergency response team structure, where you have emergency controller. Then we have isolation technical support, where you have firefighting, medical evacuation, communication, administration. So these needs to be done both in on-site as well as off-site. On-site is inside the company, off-site is outside the company. So these are the various types of firefighting system available in the industry. One is active firefighting system, one is passive firefighting system. That the sensor which activates fighting system. As soon as the fire is formed, water or any foam passive fire system is you prevent the spread of the fire actually. So we do with fireproofing material, fire retardant wall or fire enclosures. Suppose the fire happens inside the factory, so we got fire wall. The fire wall will stand for at least almost 4 hours, where the fire will not be transferred or will not be given back to the next place or next storage area. So these are the examples of various fire extinguishers, and this is an example of a fire hose reel. This is an example of a fire tender where we can go up to a height of 40 feet. These are the various firefighting systems which needs to be in place in hazardous chemical industry. The rule says that. Before going in, I want to put here a simple video of how a human error can lead to a major accident.
The Chevron lies approximately 10 miles northeast of San Francisco in California's Contra Costa County. The 2,900-acre facility was initially established in 1902 and primarily makes transportation fuels, such as gasoline and diesel, as well as lube oils. The refinery can process up to 250,000 barrels of crude oil per day. The first step of the refining process takes place in the crude unit, where crude oil is cleaned and heated before entering the distillation tower.
It is basically a manufacturing plant produces which processes crude oil. The crude oil is heated and it is sent to the distillation chamber.
Inside the tower, the crude oil is boiled. The vapor then condenses into various liquid hydrocarbon fractions, or streams, including jet fuel, diesel, and gas oil. The different streams exit the distillation tower through separate pipes or side cuts that lead to other sections of the refinery. On August 6, 2012, the crude unit was operating normally. Around 3:50 that afternoon, an operator was performing a routine check when he noticed a small puddle on the ground near the distillation tower. The liquid appeared to be dripping from an 8-inch insulated pipe 14 feet overhead. The leaking pipe was a section of the tower's number 4 side cut line, which operated at a temperature of 640 degrees Fahrenheit and contained light gas oil, a combustible liquid similar to diesel fuel. Chevron inspectors knew that over the years, the walls of the number 4 side cut had thinned due to corrosion. They did not realize how close this particular segment was to failure. There was no shutoff valve between the pipe and the distillation tower, and no way to isolate the leak. The head operator was called to the scene. Although he believed the situation was serious, he did not believe the small leak warranted immediately shutting down the unit and stopping production. Following Chevron's standard practice for responding to hazardous leaks, refinery firefighters were sent to the scene. A number of managers, engineers, and technicians gathered there informally to assess the problem. The group discussed a recommendation from an operator to shut down the unit, but they decided to first try to pinpoint the leak by removing insulation from the pipe while the crude unit was still running. They hoped they could stop the leak with a temporary metal fitting known as a clamp. A Chevron firefighter tried using a pike pole to hook and pull away the insulation, but this poking action was deemed too dangerous because it was within the pipe. The CSB later found that the tip of the pipe likely caused a small puncture in the already thin pipe. As the unit continued to operate, workers assembled scaffolding directly beneath the leaking pipe. Two firefighters then used a hook to remove the insulation from the pipe. As they were working, hydrocarbon vapor began to flow out from underneath the insulation. Two firefighters backed away from the growing vapor cloud. As the hot vapor mixed with air, it ignited. That fire was quickly put out, and the two firefighters immediately climbed down off the scaffolding. But the exact location of the leak was still obscured by the remaining insulation and firefighting water. So the Chevron firefighters attempted to strip the insulation off the pipe with high-pressure water. But the leak suddenly worsened, and hot hydrocarbon liquid started to spray out of the pipe. A decision was finally made to begin an emergency shutdown of the crude unit. But it was too late. Suddenly, the pipe ripped open. A vapor cloud formed and rapidly expanded as the large inventory of hydrocarbons in the distillation tower started to vent through the ruptured pipe. The vapor cloud immediately spread over hundreds of feet, engulfing all 19 people who had gathered nearby. The firefighters and operators struggled to escape through the dense hydrocarbon cloud, unable to see. They had to feel their way out, some on their hands and knees. At approximately 6:30 p.m., 2 minutes after the huge vapor cloud formed, hydrocarbons ignited. One firefighter was trapped inside a fire engine when it was suddenly engulfed in flames. He radioed for help. But when he received no response, he assumed everyone else was dead. To escape the inferno, he fled through what witnesses described as a wall of fire. Fortunately, all the workers would eventually flee to safety. There were no fatalities. The towering white vapor cloud could be seen as far away as San Francisco on the unusually clear August day. After the ignition, a dense plume of black smoke formed and drifted away from the refinery. The fire continued burning for hours. Over the succeeding days, more than 15,000 people sought medical treatment at nearby hospitals for breathing problems and other symptoms. During its investigation, the CSB determined that the carbon steel pipe installed in 1976 had thinned to the point of failure from an effect known as sulfidation corrosion. Carbon steel piping is particularly susceptible to this type of corrosion, which occurs over time when the steel is exposed to sulfur-containing hydrocarbons at high temperatures. Steel piping that happens to be low in the element silicon corrodes especially quickly. The CSB learned that sulfidation corrosion had caused a major failure at Chevron's refinery in Salt Lake City, Utah, in 2002. Chevron then performed an enhanced inspection of the number 4 side-cut pipe at the Richmond refinery. It revealed accelerated thinning in the piping section that would ultimately fail in 2012. Replacement was recommended, but this did not occur, and the section of piping was never inspected again. In 2009, Chevron experts recommended that every segment of high-risk carbon steel piping be inspected for corrosion. However, this was not done. During a maintenance turnaround of the crude unit in 2011, Chevron inspectors examined some, but not all, locations along the number 4 side cut and found significant thinning. Some sections were replaced, but managers decided that the line was thick enough to stay in service, and an overall replacement could wait up to 5 more years. According to CSB investigators, a key lesson is that each and every segment of the piping should have been inspected. Most importantly, the pipe should have been replaced much earlier with an inherently safer corrosion-resistant alloy. The CSB also concluded that had the crude unit been shut down when the leak was first noticed, the massive fire likely would not have occurred. The night
corrosion in the pipeline, the plant needs to shut down. But other people convinced him saying that it can be corrected. If the plant would have been shut down for at least half an hour, they would have replaced the pipeline and the plant would have started again. Decision of a person to run the line created this big havoc, but all the experience, so they were able to escape the fire. No casualties are reported in the fire. This is an example where I told you plan, do, check, act. Where planning is being done to replace the pipeline, but the do is not being happening and the check is not being done. Sir, over to you, sir. Kumar, sir, over to you.
Sir. Sir.
Tell me, sir.
Sir, sir. Completed.
Thank you for the session, sir.
Okay. Asst, madam.
Participants, this is question and answer session. You can type our question in chat box.
Asst, madam.
Okay, sir.
Sir. Okay.
Type our question in chat box. Sir, one question. How the risk mitigation and near miss differentiated in process industries? Are you hear me?
I am able to hear you, madam.
Yes, sir. How the risk mitigation and near miss differentiated in process industries? Risk mitigation.
Risk mitigation is done after an incident happens. Okay. Near miss is something which needs to be addressed immediately. Risk mitigation can be planned in the process stage itself. Okay. Mitigation is controlling the risk, that's all. The controlling the risk can be done in various methods. One is controlling the risk can be done due to engineering controls. First thing, you have to eliminate the risk. There are various hierarchy of controls in risk control. I have not gone to it. That's a separate topic for risk control. One is elimination. Second is substitution. Then is engineering controls. Then is administrative control. Then is the PPE control. So there are 5 ways where the risk can be controlled. So that is one process. First, in any stage, any process, the risk needs to be eliminated. The second is we substitute the risk with the lesser hazardous material. Third, we have to live with the risk. I'll give a simple example of the risk. For example, you are staying in a room, and there is a hole inside the room. You see a snake coming inside the room. Okay, the snake is a hazard. The risk is the probability of occurrence. The probability of occurrence is risk. Whether the snake will hit me or not, and what is the nature of the snake? Whether it is a king cobra, I will die immediately. Whether it is an ordinary non-venomous snake, I may live for a long time. So, based on the hazard, risk needs to be determined. For example, the snake comes inside my room. What I do? I block the way the snake comes. Okay. So thereby I am eliminating the snake coming inside my room. Second is I give a separate route for the snake to go inside and out. Because for example, I am in a zoo. I have to work with the snake, I have to feed the snake, everything. So I give a separate route for the snake. Where it can come inside, there is a partition between myself and the snake. So that is called engineering control. Okay. Suppose both these cannot be done in a process. So what I have to do? I have to wear a PPE, personal protective equipment. Then I have to follow a set of procedures given by the two people or people who tell me how to handle the snake. I should wear all the PPE, I should go feed the snake and then come back. This is a simple example I am giving you. Near miss is what is the action you take after an incident has happened. Risk mitigation is something you take before you anticipate the incident and then you do a control measure.
Sir, next question. What are the different types of fire extinguisher which we can use at home?
Simple
What
fire,
are the different types of fire extinguisher which we can use at home?
simple fire extinguisher is a Coca-Cola bottle. A simple fire extinguisher is a Coca-Cola bottle. In case of any fire, you just shake the bottle nicely, like a champagne bottle. You spray it over the fire. Fire will reduce automatically because it contains CO2. The best thing is a wet cloth. What you do is there are a fire occurs. First, you should understand how a fire occurs. Fire requires three things. One is oxygen, one is heat, one is fuel. Okay. We need to cut off any three of these things to reduce the fire. For example, in case of an electrical fire, in case of most fire happens due to LPG. Correct. But in case of an LPG fire, we need to close the valve immediately. Suppose I am not able to close the valve. Just take any wet cloth. Take any wet cloth. Blanket it over the fire. Blanket it over the fire, cover it fully. The oxygen supply will cut off immediately. So we can put out the fire very easily. Okay. In case of LPG fire, people, I have taken training in various schools as well as to various housewives. In case of, suppose you open the door of the house, you see LPG smell. What should I do? Best thing is, don't switch on the light, don't switch off the light. First thing. You should not switch on the light also, you should not switch off the light also. Whatever is there should be like that only. Open all the windows and doors. Okay. Then slowly go to the knob and close it. LPG will settle at the bottom of the room. Okay, bottom of the house. So after the smell goes out, wash the entire floor area with soap and then remove the cylinder out. Suppose LPG cylinder hose catches fire, what should you do? Try to remove the knob. Try to close the knob. Suppose knob also gets punctured. Take a wet cloth. Just put it over the fire. Close it immediately. Don't go towards the direction of the fire. Go the opposite direction of the fire. You should know the wind direction while you are closing the fire. As soon as if you are not able to put off an LPG fire inside the house, immediately lock doors and windows of the door and you come out. So the damage can be reduced. Any doubts, madam? Other questions, please?
Sir, what are the software used in process industries?
Sir, there is no specific software, madam. Based upon the design codes and piping and codes, based upon the various instrumentation used, there are various level of software actually. Machine, that is a separate learning called machine learning and instrumentation. See, first I need to define, this is a very big topic actually, but I tell you a simple outline. First you need to, what are the inputs required in the process, first I need to know first. Second is, what are the control measures I need to implement in the process. What is control measure? I need a prompt mechanism. For example, in the example what I showed in the slide, A plus B plus C. Okay, I have got certain conditions where there should be a minimal flow of A. Okay, so minimal flow of A is what? When can be a tank be empty? So if tank is empty, I need an alarm. Okay, the alarm needs to be audible to everybody, audible to the operator, audible to the person. That is machine learning. Machine learning and instrumentation is a various process. Depending upon there is a man-machine interface is there where you can say prompt the man. There is a control room which is available where the person needs to be educated. That is a big topic actually. Depending upon the process requirement, we can design the machine learning, design the PLC input and the output required for the process.
Okay, sir. Thank you. One more question. We are to the safety program. How to dispose any material or neutralize any strong acid or alkali after using in the laboratory safety? How to dispose?
Dispose with chemical container you are talking about, correct?
Yes. How to dispose? Any separate methods are there?
No. You are talking about chemical containers. So chemical container which is used for the laboratory, correct? Now, are you talking about the laboratory chemical containers?
Yes, sir. Yes, sir. How to dispose laboratory safely? Laboratory.
No, give me some example of chemicals used.
Okay. Uh, why cannot industries give opportunity to students in going small project on safety measurement?
Can be done, madam.
Why can't industries give opportunity to students in going small project on safety measurement?
Yes, it is being done. No issues can be given. See, first thing you are talking about the laboratory chemicals. First thing you need to have the MSDS, Material Safety Data Sheet of the chemical. Material Safety Data Sheet contains 16 parameters, as I mentioned in the slide. 16 parameters, there is a separate topic called safe and disposal method. So we have to follow that procedure for that particular chemical. First thing, you need to buy the chemical from a certified person or certified manufacturer who is manufacturing the chemical.
Okay, sir. Thank you. Sir, one person. What are the opportunities are available in safety industry as a student? Opportunities.
If you want to
Job opportunity.
If you want to take safety as a field after chemical engineering, then you should go for higher studies in MTech safety management. It is being offered before. When I studied only, there were 2 people who are offering these courses. Now a number of almost 12 colleges have come in safety courses actually. So MTech safety engineering is a blooming field in India now, as well as in overseas.
So this is a last question. Every equipment in chemical industries have same method to reduce fire accident or different? Every equipment.
Please repeat the question, me. Pardon me.
Every equipment in chemical industries have same method to reduce fire accident or different?
No. See, depending upon the chemical process, there are 3 ways of extinguishing a fire accident. One is blanketing, one is cooling, and one is cutting off the oxygen supply. Okay. Suppose, for example, in metal fires, chemical industry mainly involves in liquid as well as gaseous fires. So liquid and gaseous fires, we require a metal foam. So gases require foam material. Foam is usually used for blanketing. In any other case, CO2 can be used as a common extinguishing media. So you need to understand the chemicals involved in the process, and the MSDS is very, very, very important. It is like a Bible or Quran or Bhagavad Gita for any chemical industry. The MSDS will contain all the required data required for the process. So MSDS, based on the MSDS, you can decide the type of extinguishing media generally used. In chemical industry, we use only 2 types of fire extinguishing method. Usually, when the temperature exceeds 100 degrees, below 60 degrees, and the temperature exceeds 60 degrees, we use CO2 as a fire extinguisher. After the CO2 is being pumped into the room or pumped into the system, we go for another sprinkler system. Above 100 degrees, the temperature increases, we cool the entire reactor, entire system with water. Suppose that is also not possible, then we extinguish using foam. Foam is ultimate. It will generally cover the total fire and blanket the fire, which will cut the oxygen supply.
Thank you, sir. Most of the participants' messages are excellent presentation or excellent session, more informative. Thank you very much.
Okay.
Once again, I am Asha Devi, Assistant Professor, Department of Chemical Engineering.
Okay.
On behalf of Savita Engineering College, Department of Chemical Engineering, I propose the vote of thanks.
Okay.
My sincere thanks to our management, director, principal, vice principal, and HR manager for giving permission to conduct one-day webinar on role of chemical engineering in industrial safety. My sincere thanks to Mr. V. Narayanamurthi, safety manager at Hyundai Motor India, our distinguished chief guest of the day. In spite of his busy schedule, he has accepted our invitation. Thank you, sir, for your valuable lecture. My sincere thanks to our department HOD, Dr. A. Kumar, for his constant support for conducting this webinar effectively. Thank you, sir. Next, I would like to thanks to Dr. Karunagaran, Professor ECE, and Mrs. Badmapriya, Assistant Professor ECE, for their valuable support to conduct the webinar in good manner. My heartfelt thanks to participants from Savita Engineering College and other colleges across the country. I thank you all. Last but not the least, my heartfelt thanks to my department faculty friends and students. Thank you all. Participant, you fill the feedback form.
There are so many questions people are asking. Can I take one question and answer? People are asking about question about MTech safety management. MEPCO Sivagasi is one of the good institutes where you can study safety management. And NIT Tiruchirappalli is one of the good institutes where you have to have a gate score to enter into NIT. MEPCO Sivagasi, there is a separate entrance test where you need to enter into. And KSR system is available. Knowledge Institute Salem is available. And these are the various famous colleges at present for MTech chemical safety in Tamil Nadu. And somebody was asking about where do we learn about this ASOP study completely. ASOP study, as soon as I have given you very a small outline. To be very frankly telling you, very small outline, because as your students, ASOP study is like a ocean. ASOP study, I have given you a very small outline. Actually, I told you a check sheet where you measure all the process and write down. The check sheet goes up to 10,000 sheets for an individual process. Almost for individual process, the sheet goes up to 10,000 sheets, and we have got a point mechanism in every process. ASOP study cannot be done individually. First, people should understand. There should be people from the chemical industry, there should be people from the mechanical industry, there should be people from mechanical engineering department, chemical engineering department, there should be persons from safety, there should be operator involved, there should be a piping and instrumentation person. It can be done by a group of people, not by individual person. So ASOP study is totally based on the management to decide to do the process or not. In most of the industries, in most of the MNCs, to be frankly tell you, the ASOP is already inbuilt in the system. You first need to understand the system thoroughly. Then you can improve it automatically. It goes on a sequence of plan, do, check and act. So if you find any fault, any near misses or any hazards which are not being covered in the system, so we need to follow that also. I can show you various videos where hazards are missed also, but if you work in industry, you can understand that more. I gave a very simple video of how a procedure can go on a deviation, how a decision can play a very important role in safety. I can also show you a video how the process, if deviated, will create a hazardous element, how as well as each and every element, as well as low, high, in reaction to everything. There is a separate video for that. How people have not included all these in their hazard study. I can take a class on that also. That we come to industry, you will come to know about all that. In the initial stage, it will be too heavy for you to have knowledge of all this.
Okay, sir. Thank you very much, sir. Thank you. Thank you, sir. Thank you. Thank you, sir. Thank you, madam.
Okay, sir.
I thank the
Participant, kindly fill the feedback form before leaving the Zoom.
Okay, sir. I thank the management also for giving an opportunity to share a little bit of knowledge what I had. But learning is a continuous process. Keep learning. If you keep learning, you will go to far-off places. That's what the famous saying says. Dr. Julius is a famous philanthropist. You should have three things in basically, if you have good attitude, good knowledge, good skill. And if you keep on learning, you can go far various places throughout the world. That is the basic of learning.
Okay, thank you, sir.
Stay home, stay safe during this COVID. Thanks.
Thank you, sir. Thank you very much. Thank you.
Sir, end the session.
Okay, madam.
Wait, ma'am, let the live streaming get stopped and recording we need to stop, ma'am. Then we can end the session.
Okay, ma'am.